Hello everyone, we are Team Roborpunk. Our team wants to develop an underwater sampling robot suitable for muddy seabed environment. We found that existing seabed sampling mainly faces two major problems. Traditional sampling tools rely on vessel operations and lack mobility. However, the existing water robots are very likely to sink, sleeping, or disturb the sediment on the soft and muddy seabed, resulting in low sampling efficiency and poor data quality. And during our field test, we once encountered a situation where the robot got stuck in the mud and couldn't be retrieved. This prompts us to think about how to solve this technical gap.
We tried sediment sampling as a starting point. We purchased heavy and expensive equipment and began field experiments. But during the third test, the sampler got tangled in underwater weeds and sank into the bottom. Even when the sampling succeeded, the data turned out to be highly inconsistent. Then, we moved to robots for sampling. We borrowed a sea glide from the market. After studying its mechanism as well as searching for research online, we found a problem with current underwater sampling robots on the market. They are typically driven by propellers, legs, or wheels, and mainly focus on mid-depth or hard seafloor sampling. With a muddy, fragile seabed, they sink or lose balance, traction, and stability. Validating our innovation, we first built a track-driven robot chassis and tested its performance on muddy surfaces. The result was satisfying. The tracks did well on muddy surfaces. Then, we moved on to designing the robot as a whole using CAD. In this process, we innovatively inherited some equipment that we used in our robotics competitions. This is our robot design plan. We adopt a dual-track mobile system as the core innovation point. Unlike traditional wheeled or propeller propulsion, the track design can significantly increase the ground contact area, providing better traction and anti-sinking capability on low-load muddy terrains. This ensures the stability and possibility of the robot during operation. On the track's chassis, we have integrated sediment samplers, water quality sensors, and navigation systems. This design enables precise and low-disturbance sample collection and environmental data monitoring while on the move. Our product positioning is clear. It focuses on solving the specific challenge of stable movement and sampling on soft and muddy seabeds, providing targeted operation tools for relevant research teams. Meanwhile, its reliable structure and intuitive operation also make it suitable as a practical platform for STEM education. Compared with traditional sampling methods, our robot has achieved controllable mobility on the muddy seabed, breaking through the limitations of the original operation mode. Compared with other underwater robots, we have specifically optimized the anti-sinking and anti-skid performance in terrain with low bearing capacity, which has significant advantages in this specific scenario. At present, we have completed the principal verification and preliminary design, and we have carried out cooperative discussions with some research institutions and schools.
For the outlook part, our development plan is divided into 3 stages. In the near future, we will focus on the improvement of prototypes and pattern applications. In the medium term, plan is to verify the product performance for cooperation with educational institutions and research units. The long-term goal is to establish a stable production and service system. We believe that this technology can not only provide support for regional marine research, but also has the potential to become one of the standard tools of monitoring global vulnerable marine ecosystems. By providing more accurate and accessible data on the seabed environment, we look forward to making tangible contribution to global climate change research, marine biodiversity conservation, and the achievement of sustainable development goals. Meanwhile, we are committed to building this platform into an important carrier of international STEM education, stimulating the interest of global teenagers in marine science and engineering technology, and jointly cultivating the next generation of innovators who can address future environmental challenges. Thank you for watching. We look forward to working with partners around the world to contribute to understanding and protecting the global blue planet.